Lesson 9.4 is about rectangular prisms. We're going to be working on volume and surface area for rectangular prisms today. Rectangular prisms are down on the bottom of your formula sheet. It's on the bottom right-hand side of your 7th grade formula sheet. We are going to be in your notes packet on page number 8 for this lesson. Volume of any given 3D figure is the measure of space it occupies. It's going to be measured in cubic units. Three-dimensional objects, remember, have length, width, and height. There's something that we can actually hold in our hand. So in order to work with this one, when we find volume, it's going to be space that it actually takes up. So when I'm holding it in my hand, how large is it? So for example, if we have this rectangular prism right here, we can see that it takes 2 layers of 36 cubes to fill this box. So the volume of the box is 72 cubic centimeters. Because it is 3-dimensional and volume is 3-dimensional, our units are going to be cubic. So they're going to have, for example, inches cubed, feet cubed, or we can write out like cubic units if we wanted to. For surface area, we are looking at the total area of the surface of a 3D object. And it kind of helps to take us back to looking at nets then to be able to remember what the surface is actually going to look like. So surface area is kind of directly related to our nets. And we're going to be taking a look at a formula that we have for rectangular prisms that kind of makes it a little bit easier for us. Note that on rectangular prisms that the opposite sides are actually exactly the same. So you're going to see that kind of in our formula here. So to find volume for a rectangular prism, our volume formula, we're just going to take the length times the width times the height, and we're going to multiply those 3 together. In the surface area, we have 2 times the length times the width. So the length times the width is actually the bottom part of the rectangular prism here, but because the bottom matches that top, that's why we have 2 of them. The next part is the length times the height, which is going to be across the front here and times the amount up the side. So that's going to be the front as well as the back of our rectangular prism. And then finally, 2 times the width times the height, that's going to actually happen over here on the 2 sides. So we have the 2 opposite sides that are going to be exactly the same. Finding that surface area, we're finding the area of all those different outside pieces that are to the outside world then on that prism. So in our first one here, we have example number 1. Our length on the picture is 5. This matches up with our formula sheet. Our width is going to be 4, and the height is over here going to be 3. So width is 4, and the height is 3. I'm not going to worry about units until the very end here. For volume, my formula is length times width times height. I'm going to keep marking this as V equals, so remember it's volume, and I'm doing 5 times 4 times 3. So the volume here is going to be 60 cubic centimeters. So we put centimeters with that little exponent of 3 because we're talking a 3-dimensional measurement. Surface area is this long formula. We have 2 times length times width plus 2 times length times height plus 2 times width times height. Keeping my SA out front to represent surface area, I'm going to plug in my numbers. 2 times 5 times 4 plus 2 times 5 times 3 plus 2 times 4 times 3. For surface area, because it's a good chance that we can make some mistakes, I'm going to ask you to kind of group these into these 3 pieces first. 2 times 5 times 4 is 40. 2 times 5 times 3 is going to be 30. And 2 times 4 times 3 is going to be 24. I then would recommend that you go ahead and add those up. That gives me a total of 94. My units here are centimeters, and remember this is an area. It's a 2-dimensional measurement, so we are going to have that as centimeters squared for this one. Flipping it on over to page number 9, example number 2 says a fish aquarium is shown. How much water will the aquarium hold if it's filled to the top? When we're talking about holding, that's a capacity. We're filling it to the top. Filling tells us that we're going to be finding volume. When I look at my picture, this is my length, this matches my width, and this would be the height of the tank here. Volume formula is length times width times height. We're going to plug in 24 for our length times 12 for our width times 14 for our height. Taking a calculator, 24 times 12 times 14, we get that our volume is 4,032 cubic inches. I'm going to add the label of water because it says how much water will it hold if it's filled to the top. In example number 3, Dom built a toy box 60 inches long, 24 inches wide, and 36 inches high. He has 1 quart of paint that covers about 87 square feet of surface. Does Dom have enough to paint the toy box? So noticing these are all in terms of inches, but then the paint is in terms of square feet. I do notice that these are all divisible by 12. So I'm going to write down my side. Length equals, width equals, and height equals. If I were to change this into feet, I would do 60 divided by 12, and that's going to give me 5 feet. If I do 24 inches divided by 12, that's going to give me 2. If I do 36 divided by 12, that's going to give me 3. Dom is painting the toy box, which means I'm covering the surface of it. So we're talking about surface area. My formula is 2LW plus 2LH plus 2WH. For my surface area, I'm going to plug in 2 times 5 times 2 plus 2 times 5 times 3 plus 2 times 2 times 3. Grouping these up into the 3 different parts here, 2 times 5 times 2 is going to give me 20. 2 times 5 times 3 is 30. And 2 times 2 times 3 is going to give me 12. When I add all those together, I get 62 square feet. So Dom has the 1 quart of paint. It covers 87 square feet. My space is only 62 square feet. So when I do that, I can say yes, 62 square feet is less than 87 square feet. So he has enough. In example number 4, a toy company makes rectangular sandboxes that measure 6 feet by 5 feet by 1.2 feet. Customer buys a sandbox and 40 cubic feet of sand. Did the customer buy too much or too little sand? Justify your answer. So since we're filling it with sand, we're talking about volume, which is length times width times height. My length here is 6, my width is 5, and my height is 1.2. To find my volume, I'm doing 6 times 5 times 1.2. That gives me a total of 36 cubic feet. So since the customer bought 40 cubic feet, the customer has too much sand. They only need 36 cubic feet. So they'll actually have 4 cubic feet left over then. Our final example here is example number 5. When wrapping a gift, Amy adds an additional 20 square inches to allow for overlap. How many square inches of paper will she use to wrap a book that is 11 inches long, 8 inches wide, and 1 inch high? The length is 11, the width is 8, and the height is 1. Since she's wrapping this book, that's going to be surface area. 2LW plus 2LH plus 2WH. Surface area equals 2 times 11 times 8 plus 2 times 11 times 1 plus 2 times 8 times 1. Grouping these into the 3 sections, I get 176, I get 22, and 16. When I add those together, I get 214. Don't forget, Amy's adding on an extra 20 square inches for a total of 234 square inches of paper needed. That's it for volume and surface area of rectangular prisms.